Meron tayong bagong gagawin. Ito ay car robot kit. Diba? Para saan naman yan? Okay. Nagawa tayo ng car robot. Assemble natin. Dalawang gulong, motor, meron pang coaster, body, at mga pyesa, tornilyo. Assemble na natin. Ito na ang ating car robot. Buo na. 'Di ba? Na-assemble na natin. Dalawa yung gulong niya. So dito, dalawang motor. Mga tornilyo niya, pwede mong i-adjust yan. Dito, may adjustment yung kanyang height. adjustment. At yung kanyang lalagyan ng wire nasa labas, outside. Dito yung coaster, meron siyang spacer. May mga tornilyo. Oh. Okay na siya, di ba? Ay, tutoy. Mukhang may bago ka na naman laruan dyan. Ha? Ano ba yan? Ito yung ating kutsi-kutsihan. Car robot. Oh. Ano naman ang ano yan? Hindi naman tumatakbo yan. Ha? Patatakbuhin natin ito. Kukontrolin natin ito. Ano ka? Paano tatakbo yan? Aba, kailangan natin ng ano yan. Ito. Oh, kita mo ito? Battery holder. Pangdalawahan. Meron siyang wire na kasama. Positive, negative. Naka-series yan. At ang gagamitin natin, battery, ito. Ano naman yan? Ha? Oy. 18650 battery. Ayun, oh. Positive niya yung flat head. Bottom, flat. Diba? Oh. Dalawa. Dalawa yan. Paano tatakbo yan? Aba? Kailangan natin ng driver. Siyempre, sino magmamaneho niyan? Walang driver. Nasaan ang driver niyan? Ito ang kanyang driver. Kita mo ito? Ano yan? Ito yung tinatawag na L9110S motor driver. Gagana ba yan? Ha? Aba, kakabit natin para makita mo. Diba? At gagawa tayo ng controller. Subukan na natin na ikabit. Diba? Good day to everyone. We have here the axle module L9110S motor driver, and this is the module itself. And as you can see here, I made some reverse engineering of this module, for this module. So this is the actual module, the same, and the connections, I traced the connections and all the components connections. Okay, and this one, we have the equivalent circuit diagram or the schematic diagram for L9110S motor driver. So in our diagram, we connected two motors to the circuit. So these two IC, which is located here, the two ICs, each IC or the L9110S IC is an H bridge. Okay, since it is two, it is now a dual H bridge motor driver. Okay, H bridge is one way of connecting a motor to rotate, to change the direction of the motor. That is the H bridge. Let us see the diagram. We are using 7.4 volts. Why is it 7.4 volts? Because we're using two 18650 batteries, and one 18650 is 3.7 volts. If that is 3.7 volts times 2, in which the battery is connected in series, so it is equal to 7.4 volts. And then to our circuit, we have these two capacitor. What is the use of these two capacitors? C1, 0.1 microfarad, and C2, which is 10 nanofarad. What is the use of that capacitor in the circuit? Well, the use of the capacitor in the circuit is act as a coupling capacitor to stabilize the circuit, to eliminate noise level or the noise line noise. Okay, so it is connected to the positive and then to the ground. Where is it? Should be connected to the, this is connected to the ground, not here. Okay, connected to the ground. C1, C2 should be connected to the ground. Okay, to the ground. Here, connected to the ground. So this is connected to the ground and to the positive. And in the positive, we have this power LED. Okay, D1 red with a current limiter of 1K resistor. What is the use of this power LED? It is used to indicate that the circuit is on. While powering the circuit, we will now know that the circuit is on. It is located somewhere here. So when we see this LED turns on, it means that the power or the circuit is on. That's why there is a power LED. And one IC, you can see it's the unit 1 UI. And this is the L9110S motor driver. The pin 1 is the output A. Okay, which is connected to the motor. We connected that in our video. And then again connected to the pin number 4, OB, output B. So it is capable of a forward and a reverse direction, capable of doing a forward and reverse direction. Because the motor has a polarity, you can interchange the polarity of the motor, or we can calibrate the motor for what direction we're going to do, or we're going to what direction. And for pin 1 and pin 4, we have this capacitor. What is the use of this capacitor? 0.1 microfarad. This serve as a stabilizer to the motor itself, because the motor is capable of changing, because the motor is always changing the direction of its rotation. So it regulates the, upon the changing of the direction of motor, it regulates the current, or the voltage and current for the motor. Usually when the motor is carbon type, or brass type motor, the contact of the carbon brass, so it help to regulate, stabilize the brush motor, usually the brush motor, or the motor itself. Pin number 2 and pin number 3 is connected to BCC. Okay? Remember that these two capacitor are connected to BCC and into the ground. But here, pin number 2 and 3 connected to BCC. Okay? That is the power of the motor driver. Pin number 5 is ground. Okay, ground. And then pin number 6, we have this connected to pin header number 2. Pin number 7, pin header number 1. Pin number 6 is also connected to the resistor R3, which has a value of 10K. And pin number 7, R2, 10K, with a value of 10K, and they are connected to the power supply. As you can see here, pin number 8, grounded, ground. And you see also here that the R2, the resistor, is connected to the power, and then to the pin number 7, also to the pin number 1. What is the function of this resistor? It will serve as a pull-up resistor to pin number 7, so that the IC will work properly. For the IC to work, we need this pull-up resistor. Okay? To ensure that we have a continuous good connection between the IC and to the supply, the R2. Number 6 is R3, also with a pull-up resistor to stabilize the pin connection, or the input, because these two are inputs. Okay, this pin number 1 and 2 of the pin header is an input. Since it is pull up, so the IC is good, or working. It is almost the same, has the same connections with the another IC, is the U2, also the motor driver. Pin number 1 also with the motor, and then the capacitor, then OB, 2, 3, BC, connected to BC. 8 also grounded. 7, 6, 5 grounded. 7 is connected to pin number 5 of the pin header. This is the pin header. Okay, you can see here the pin header. Pin number 6 connected to pin number 6. Pin number 7, pin number 5. Which is also connected is the R4 for the pin number 6, and then R5 for pin number 7 with a pull-up resistor. Okay, so the IC will work, will function. If there's no resistor here into the input of the IC, it will not work properly. So we need a resistor, pull-up resistor, to maintain, to stabilize the circuit for this IC. We cannot leave this pin of the IC without any connection, either grounded or pull up, because it will hang the circuit. It will not work properly. So here, pin number 1, 2, 3 is the BCC connected to the 7.4. 4 is the grounded. It's the same here. 5 for the pin number 7 of IC2, 6 to the pin number 6 of IC2, 1 for the pin number 7 of IC1, 2 to the pin number. Remember that this terminal or this pin, they are for input or for the controller. Okay, we're going to make a controller for this to work. So in our circuit, we connected already the motor, and then we have now the functions, the pull-up resistor. You need to make it always in the positive, connected to the supply, the pin number 7 of both IC, and pin number 6, which also connected to the pin header. And this pin header is, we're going to connect our controller. We're going to make our own controller. Okay, we now come to our new circuit. So here we added the switches for our controller. So the controller is a push button connected to the pin header. So for our controller, the switch 1 push button connected to the pin number 1 of the header, and then the other end is connected to the ground. Switch 2 pin number 2 of the header connected to the ground. Switch 3 is BCC, although supply voltage of 7.4 volts, and connected is this is the power LED of the controller of the push button. We're going to add a 4.7K resistor in series with the LED red, just to know that our controller is on. So we need to add this circuit ground, pin number 4, and then pin number 5 of the pin header connected is the switch with switch 3, then to the ground. Pin number 6 is connected to pin 6, and then to the ground. Okay, so we added this circuit. We're going to add this also we're going to add the power LED of the controller. So when we press the button, okay, it will send, since it is connected to the pin number 7, it will send a logic high. Okay, and if it is logic high, since pin number 7 is the input of motor A, the output now will make this motor to rotate in clockwise. Okay, so pin number 7 will rotate the motor in a clockwise direction. If pin number 6, which is connected to the pin 2, when we press the button of the pin 2, it will, the resistor, since it is a pull-up resistor, it will now also pull down. It will pull down now the resistor to the ground, causing it to have a logic 1 here. If we press only switch 2 of the pin header, it will rotate the motor in a counterclockwise. So if we press switch 1 clockwise, switch 2 counterclockwise. If we both press the button, it will stop from rotating. So for our logic, for the logic control, if this is pin number 1, number 2, okay, and we have the table here, and the output, for the output, let us say series the output, pin number 1, pin number 2. Let us simulate the logic control. If we do not press 1 or pin number 1, it will send a 0 here, and then also we did not press pin number 2, send a 0 to the input, so it has a logic 0 0, because we did not press the switch. And the output, there's no output for the motor. It will not move, or it will not rotate. While if we're going to press pin number 1, so it becomes 1, logic 1, or become a high level, logic 1, it will turn on the motor. It will rotate in a, let us say, clockwise, and pin number 2 is not we did not press the pin number 2, that's why it's logic 0. If we're going to press only the pin number 2 for the switch, sending a current to the pin number 6, it pulls down the resistor, producing a voltage. So for the logic, it will become 0 for we did not press the pin number 7, and 1 for the logic of the pin number 6. So it will rotate on clockwise. It will rotate on clockwise, okay? Here. For the logic, 1, pin number 1, 0, we did not press. And then, we press pin number 6, which is in pin number 2, the switch. It sends a logic 1. It sends a logic 1. It will turn on the motor, rotates in counterclockwise. For if we both press the switch, it will not move. Okay? That is the brake function of this logic control. So that is the logic control. Same as here. Okay? Also have a resistor, R4 to the 7. So if we send the logic 1 to pin number 5, it will rotate the motor. And if we send logic 1, or if you press the switch, it will rotate also the motor in clockwise and counterclockwise. So logic control refers to the pressing of the switch, manipulation of the switch. So we have 4 logic control, because we have 4 control. 1, 2, 5, 6. If we were going to press 1, it becomes 1 here. 1, or it's connected to pin number 7. For the pin number 1, connect pin number 7, becomes 1, 0, 0, 0. We were going to press 5, it becomes 1 and 1. It will rotate clockwise. At the same time, this motor rotates clockwise because we're pressing pin number 1 and pin number 5 is activated. The 2 switches are activated. That is the combination of the switches. So all in all, a logic control refers to the combination of the switch, pressing of the switch, pushing the button. That is the logic control I am referring to. Okay? You can, you can calibrate the motor. You can switch the polarity. It's either negative here or positive here, because motor has no polarity in general. It only has some polarity when we are connected it to the DC, directly to the DC supply. But while connecting in a H-bridge type motor driver, it has no polarity. You can interchange the contact or the polarity of each motor to calibrate, to tune up, and to orient. You can reorient the motor in any direction. It's either clockwise, counterclockwise, forward, or reverse. So all in all, a logic control refers to the combination of the possible outcome whenever we press the switch. Combination of the pressing of the buttons. So in short, it will not short the, in summary, it will not short the pins since it is IC. We have 2 dual H bridge connected to the 2 motors each with a logic control using a push button. So our controller is a push button.